morning everyone. I am Vaibhav Karsh. I am currently pursuing my BTech in Artificial Intelligence and Data Science from IIIT DMU Kurnool. So today I will be presenting my work on the project titled Multimodal Oncology Assisting using local inference via OLAMA. So this my project is based on using multiple modalities of inputs like images, tabular data and text-based data to determine whether a patient has cancer or not. So, so this can be used for various use cases where people can have preliminary reports using an AI system which will help them to get a early diagnosis whether they have cancer or not without going to a doctor. So for this project, what we have done is we have trained different models for different modalities. Like for image-based data, we have used a CNN-based model where the backbone we use is efficient net. So this is used for this is trained on the image data from lungs, brain, skin, and breast cancer. So this vision expert will be used to detect whenever the input data is image based. Then for the table based data, we have used XGBoost model to determine whether the patient has cancer or not based on the features available in the data set. Then from both these modalities, we have used a land graph based router which will redirect the input query to the appropriate model based on the data. So like whenever a person gives a data which is image based, so the router will redirect that query to the vision expert data endpoint. So this way it will be answering the appropriate queries using the appropriate models. So, but we cannot blindly follow or accept the results provided by these models. So what we have done is we have used Monte Carlo dropout to explain the reliability of these predictions. So whenever a model is not confident about its prediction, it will give a confidence score I am 20% confident about the prediction I have gave. So to give a better explainability and reliability to the predictions, we have used the Monte Carlo dropout for calibration and the grad cam to show which part of the data is contributing to the results of the AI system. So for this we have used multiple types of data sets. Like for image-based data, we have used the data set for breast cancer, lung cancer, skin cancer, and brain cancer. And for table-based data, we have used the data set for breast cancer and lung cancer only. So this is to give a basic outline of the architecture we have followed. Like this is the input node where we will give the input data in whatever modality it is. Then it will be sent to the router node, which will decide based on the modality of the input which expert should answer the question. So like by default it will go to the vision expert, which will use it and infer the result from the input data. Then it will be passed to the tabular expert, which will use the XGBoost model to infer the results. Then we are using the fusion module. Like if we have multiple data sets for a specific situation, like we have the blood test result, diabetes result, and other test results, and along with the scan. So this fusion mode combines the data from both these data modalities into a single consolidated text, and this will pass through a synthesizer mode where we use the spend 3.5 2 billion model to synthesize a consolidated report about what conditions the patient is suffering from, and it will use the input data and the result from the vision and clinical expert to give a brief report on what the patient should do. So as I mentioned, we have used for the image expert, we have used efficient net backbone for the vision expert, and then this MC dropout, which is multicolor dropout, to show the confidence of model in its prediction. And for better explainability, we have used GradCam to show which part of the data or which features of the data are responsible for giving its prediction. Like whenever it is red, it is based on the data, it is red or green. Then for the table-based data, we have used XGBoost algorithm as it uses gradient boosting mechanism to boost its prediction, and it works well with both kind of problems like classification and regression. Then for the model fusion, that data fusion that we said, it accepts results from the vision expert and clinical expert based on the probability that it is contributing meaningfully to the result. Then to show one example, I have done one problem. Like whenever we give an image, like let me show a real example. Like if we give this image to the model and analyze now, it will give its analysis in 2 seconds. So it shows 93%, which means there is a high possibility that this sample is having cancer. And to show uncertainty, it shows like it is 84% certain or confident in its prediction, and it shows the overall risk is high. And as for the synthesize, and as we can see using this GradCam visual, like this part of the image is most useful in reaching this result. Then as for the synthesizer mode, I said the synthesizer node takes the input data and the results from its analysis to give a brief diagnostic report about what the report or summary of that result is. Like the AI detected something concerning in the image, the probability is 94%, it means it is very high. Then if we want to ask a question in any language, it will answer in that language only, which means it can answer queries in any language which the user enters. Like let's say I entered in English, so do I have cancer? Should I visit a doctor? So this chatbot will answer our query in whatever language we ask it. So first it shows sympathy for the person who asked the query. Then based on the result it answered, the AI identified a lesion in your skin that showed 93% probability of cancerous cell. So, and the second part of the question, should I visit a doctor? Yes, absolutely. So this system gives us a preliminary method or a chance to analyze the reports ourselves and to get a verdict uh, whether we have to be scared or not, and whether we should consult a doctor or not. And to show like example in another language, I have already done an example for this. So like this is the another sample for skin image. Then I asked the system क्या मुझे कैंसर है, and it answered सबसे पहले that same sympathy thing, and based on the context कैंसर की संभावना 70.9%. And like this is the third example. This is for the brain, and if we give the image, then it shows 7.6% it is not cancerous. The same diagnostic report based on the result. And if we ask the question, do I have cancer, and the same response based on the result, that whether the person has cancer or not.